Hello, everyone, and welcome to this webinar about using CSCs cloud services about CPouta and Rahti for GIS. And I can see that there's already 14 participants in the meeting room. And maybe somebody else will join soon, but we can start. My name is Eduardo Gonzalez, and I am a GIS specialist here in CSC, and here together with our GIS team we have been developing these instructions to help our users to use CSC cloud services for your computing purposes. And I was thinking that you can ask questions here in the chat box in the Zoom environment, and I will be looking at questions. But if a question is a bit longer, I might reply to it later on at the end of the webinar. But if it is short enough and related to whatever topic I'm discussing about, I might actually answer it directly. But I wanted to present today our two main cloud services in CSC, and these are CPouta, or actually Pouta in general, which is a platform where you can develop your own virtual machines, where you can install any software that you might need, including your computing related software. And a second platform that we have here in CSC is this Rahti, which is a container platform where you can distribute your containerized applications. We'll see that a bit later. And specifically, we have this Github Repository, which is a public repository where we have been collecting and will continue collecting and developing instructions that will help you in setting up your environments, specifically for GIS or geocomputing purposes. At the end, I will also show how you could read these instructions, or quickly just go through a couple of examples. One about GeoServer and another one about setting up a Python environment in Rahti by using the instructions that we have. So I will kind of quickly go through the instructions, and we'll try to show you what the instructions will lead you to. And you can head these slides from the link that you can see now in the chat box, or from the course. Well, this is the link to the course page, or the webinar page. And later on, I'm sure that we will record and process a little bit this webinar so that you can go back to see specific parts that you might be more interested in. So about CSC cloud services, one thing that actually is important to note is that CSC maintains and develops one part of the infrastructure of the platform, but most of the end use need to be developed by the user himself or herself. So meaning that, for example, for CPouta or for Pouta platform, we take care of the Pouta web platform-based platform, where you can have access to the computer resources, CPUs and RAM, memory, and so on. And actually, even though it is included here, this OS, operating system installation, would be some of the tasks that the customer, the user, you would have to perform, actually, we have a set of basic operating systems that you can start from, being Linux operating systems anyway. But any other thing that you may need to be running on those virtual machines are responsibility of the customer, of the user. And for the Rahti platform, things are quite similar, but Rahti being a container platform, instead of needing to install, as you can see here, this operating system and some these other elements of your platform, you end up by needing to install only your data sets and applications to this using this Rahti platform. This makes things easier in a way, but definitely you need to also learn about this Rahti platform management, which is also not that common environment. So it makes things easier from one side, but it includes a new element that you need to learn about. And you have to use Docker or containerized applications, which might also be something that you're not used to. But these are the main two platforms that we have in CSC. And going back to this same topic, that what parts are provided by CSC with these platforms and what parts the user need to be responsible and to develop by him or herself. You can see in this slide, we have I have this separated what parts are managed by CSC, definitely, which mainly means hardware and kind of the platform that makes the resources available, whether as via CPouta or via Rahti. So on the left side, you can see also some kind of recommendation. It's not necessary that a researcher, if you are a researcher, you might not need to be aware of these IT administration tasks, but these are actually meant to be maintained by the user, so yourself, but that doesn't mean that you need to do them by yourself if you are not a system administration specialist and things like that. So you might actually want to ask your IT department for help on setting up these environments. And in the end, anyway, you need to install software by yourself and to manage data and things like that. And that also requires skills related to computer sciences. So you can always help find help from IT support of your own organization. And definitely we always try to help, but this is something that we don't provide by default. But you can always ask, and we try to help you develop your own environments. And as part of CSC's work, the instructions that we will be looking at in GitHub are a part of this, helping you setting up these environments. And I added also this slide with this has a bit more detail on what kind of skills or activities you need to do and different stages or creating your own computing environments, whether in CPouta or Rahti. But this is perhaps only as a reference. Now I would just a few words about each of the platforms. So for Pouta environment, as I was saying, this is a infrastructure as a service. So you get a platform where you can actually create your own computing resources, say as a virtual machine, where you can add different components as RAM memory or CPUs or even different volumes and things like that. So this is what the Pouta platform is about. You can create your own hardware configurations. And this is not, this is very similar, or actually very similar to what Amazon Web Services are, at least for some of the parts of Amazon Web Services. So, and we have in CSC these two kind of PouTA services. CPouta is the general use one, and then we have this ePouta, which is meant to be used for applications where you have sensitive data that needs to be protected or managed in certain ways. You can ask from CSC more information about this, and some specific technical detail, for example, that this PouTA has been already in production here at CSC since already a few years, and that it is powered, or it is an implementation on OpenStack. So these OpenStack tools are the ones that you would use to manage this PouTA, CSC's PouTA platform. And as you could see here at the end of the slide, there's different ways to interact with this PouTA platform, where you are creating these virtual machines. There's this web user interface, and this CLI stands for command line interface. So you can write commands to create virtual machines or manage your images in your PouTA project. And even there are different APIs that you can use for interacting with the platform. And just a quick view of what this PouTA web user interface looks like. There is 4 different screenshots in this slide. And this is what you would more or less find when you are looking at your PouTA projects. And if you see in the lower left corner, screenshot instances stand for your virtual machines or virtual servers. You can call it any of those things. And you could see that in this example, you have 3 lines, and each of them stands for one virtual machine. And you can see the name of the virtual machine and what is the image that it has been created from, and what is the different IP addresses that these machines could have installed or attached. So it's this kind of environment where you actually are managing virtual machines creation. You are not actually using the machines from this interface, you are just creating them. And another very recommendable way of using this platform is to use command line interface. So by writing commands, you could easily repeat the steps that you would be doing by clicking on the web user interface. And of course, visually, it is always nicer to do some basic steps, but when you are ending up repeating the same clicking several times to perform a very simple task, you realize quite quickly that this is actually quite easy to. There must be a way that you can write this in a script where you repeat those steps without needing to click around. So this command line interface are actually extremely useful once you are getting started with, or you have been already using this platform for a while. And definitely your IT, or if you are an IT person, the command line interface is something that you would really want to quickly get acquainted with. And again, going back to what service requirements is perhaps more what is required from the user. So to be able to make a good use of this platform, you would need to actually have some idea about what a virtual machine is, or a server, and including what security issues mean and how are they actually defined, meaning firewalls and some similar things. And you would need to be able, and if you start to use these PouTA services, you eventually will know how to do these things You can see from our PouTA documentation many instructions that will help you with the process. But you will end up knowing how to connect to these virtual machines and how to transfer files back and forth from your local computer if it's necessary and similar things. And definitely you will need to be able to install your own software or components by yourself. And this most of the often means that you are managing Linux distributions, operating systems, maybe Ubuntu or maybe CentOS, similar things. And if you need to do backups, you need to actually arrange them yourself as well. And if you're just a researcher that really don't want to learn about this IT administration, you could actually use some help from your IT support. And this actually makes a lot of sense because these are quite specific things that are obvious for IT personnel, but it's not so normal for researchers to know. And there's a link here that you can use to see some more information about this PouTA platform. And so you can use this link and our GIS GitHub instructions in combination, so you can actually get quite far in the making something useful of this PouTA platform. And for Rahti Container Cloud Platform, it's already so-to-called platform as a service. As before, this PouTA was infrastructure as a service, or by infrastructure perhaps meaning a hardware infrastructure. But in Rahti already, you have several things already set up for yourself, for your use. And in that way, that might be a platform where you kind of connect ready-made applications that actually are containers. So as opposed as in PouTA, that you would install your whole set of software tools and similar things, in Rahti you will be able to just simply plug in a container that contains already several applications or a set of applications. Of course, the catch-up is that this container needs to be ready, and if it's not a container that is already existing, then you may need to make your own container. And technically, Rahti is a OpenShift distribution. Red Hat's distribution of Kubernetes, which is a platform where you can run these containers. And in many even complex ways, although for the uses that we have been testing so far for geocomputation, we use very simple applications, just simply one container. Although with these Kubernetes platforms, you could actually combine many containers to work together with different applications that would be actually creating kind of a larger service. But more about Rahti, this is actually a platform that is built on top of CPouta. So basically, if you have the resources enough, you could actually get your own Rahti platform, Rahti-like or Kubernetes application installed in PouTA. But that would be actually a waste of resources because it's already done for you. So you just simply need to make use of it. That would be actually the best way. But in theory, this OpenShift distribution is open source, so anybody could set up something similar, but probably many resources would be necessary. So for that reason, we have already done this for researchers, and you could just simply make use of it. And currently, Rahti is still in closed beta, so it means that it's quite hopefully soon going to be open, but you can request for user account to it if you think you are interested enough in giving it a try. And as of course, as before with PouTA platform, you have also this web user interface and this command line interface. So in Rahti, as I was saying, you run containers which need to be ready-made, and if you have a complex container setups, you could actually probably set them up also in Rahti. But that would start to be requiring a lot of knowledge in this Kubernetes and containers setups. And of course, as I was mentioning before, this you need to have these software stacks made into a container ready. But its containers are quite a popular format, so it might be that you can find several container applications that are already ready, and you should try to make use of them. Or if not, you could start up with one base container and create your own, which is what we are doing later in the short demo about this Rahti applications. In the end, you are running your applications or computing environments in the cloud. As in PouTA, you would need to create your virtual machines and develop your own software stack in there. And in Rahti, you don't have to do that, but you have to actually manage these containers. So you can perhaps choose the one way to work which suits, which you are more familiar with. And this is what Rahti web interface looks like. It's actually quite a nice web interface, but it will require some time to get used to it, but we can see a bit later about in a short demo. And like for PouTA, you would need some skills so that you can make use of this platform, and definitely you need to know how to manage, create, and test these Docker images and containers, and how these containers need to be customized or modified to properly run in Rahti. And you need to know some OpenShift platform management, which actually means whether you can do a lot of things from the web interface, but you most likely won't like to know how to manage this OpenShift platform and your projects with the command line interface. And for that, we have some instructions in our GIS geocomputing GitHub that can help you at least to get started. Plus, then there is you can check on the OpenShift documentation itself and Rahti's. And I would recommend that you have some advanced application development skills for getting this, especially if you are going to be customizing your own Docker containers. But your IT organization's IT personnel could help with this Docker environments and Rahti tuning, plus implementing your own custom containers. And here you can see the link to the Rahti's platform, and there's some documentation in there about how to use it and links to the appropriate documentation. Right, but that's for the whole both cloud service platforms that we have at CSC. And just quickly, just a short list of kind of GIS or geocomputing cases that could apply well in the cloud. And things that we have been testing are mainly listed in here. For example, you could run specific applications. You could run these ones in your own local computer, and it might be that some of these applications we have installed in our supercomputer environments, but sometimes these things are not possible for one reason or another. Then you could actually turn into this cloud services, because the supercomputer environments that we have at CSC are managed by ourselves and have several limitations. So you cannot actually install anything you like in there. You can install several things, but not anything. And even us would have problems to install some things. And for example, this European Spatial Agency SNAP software, we have been installing it in the cloud before we have been able to install it in our supercomputer. And for example, running Docker containers is not possible in our supercomputer environment. So we have been testing and running them in our virtual machines, or even in Rahti's platform. Setting up computer classes with the same setup for all the students, for example, is something that is much easier to be done in these cloud services. And web servers as GeoServer or Map server definitely are better fit for this cloud than for a local computer or supercluster. And the same goes for databases as PostgIS. And we have even some instructions about ArcPy, how to run Linux tools in our cloud server. So basically all the things that are, or most of the things that are in this page are taken from the GitHub repository of geocomputation that we have. So you could actually use those instructions to set up one of these examples. And GeoServer, you might already know what it looks like, but we will see about this, how to set up this specific one in CPouta, or how to quickly you would actually be able to set this up, depending on your starting level of skills. If you have been working with Pouta and you are skilled in Linux applications and so on, it might take you a few minutes. If not, then you would have to little by little learn one thing at a time until you get to this step. But it just requires some time. Another example that you could set up is a web application. So in this case, I think this was from Finnish Geodetic Institute, nowadays National Land Survey, part of National Land Survey. And in this case, it's a setup of a computing cloud server plus a front-end application. So you could set up this kind of applications using CPouta. And I was mentioning about this possibility of creating these environments for courses where students would have a same environment that they could use for the course. This is something that we implement with Notebooks, which is a CSCs service. It's not included in the main part of the presentation because it's basically a service where you can plug in your existing containers as long as you get access to the platform. But it's very little that the user can actually do in the end. You just need to get things ready and then just set up one of these applications that will be used for your students to log in. But most important for today, actually, even though this is left for the end, is to give you a glance of our GitHub repository for geocomputing examples and on how to use it. So because these cloud computing services are very much putting the responsibility on the user. The user needs to have a lot of knowledge about how to set up their own applications. Then we try to, besides the official documentation about PouTA and about Rahti, then we have tried to get a collection of tested instructions on how to use these PouTA and Rahti platforms for geocomputing applications. In the end, we have also some instructions about general use, but the original goal was to get instructions to help setting up GIS or geocomputing applications. And this is the web page where you have to go to get these instructions. So it's a Github repository, and we have it in the CSC training main repository or main folder, and then its repository is geocomputing. So you will find there a lot of instructions, including something for the supercomputing environments. Here you can see at the beginning this Python and R links. Those you might be interested in having a look at them later on if you want to know what it's about, this supercomputing environment and how to use it. Has plenty of interesting documentation and examples and code snippets and similar things. But today I just will quickly go through these two links at the bottom about PouTA and Rahti, and mainly about PouTA. Right, so let me quickly change to the example of GeoServer. So, or basically, I can actually demonstrate quickly or show you what this geocomputing repository looks like. So when you would log into this address, you can see the same thing that you would see in the slide a moment ago. And we have been creating a bit of a hierarchy. So you don't need to use these ones right now, but you can just usually use the links in the README file. So if I would go to this, just show you how these are more or less structured. If you will go to the PouTA GIS examples and instructions, what you actually end up is with this entry page to these instructions. And actually you can see that the beginning is general PouTA instructions. So even though there is the PouTA main documentation, we found out that it's good to have a clearer walkthrough setup of instructions that you can follow up to get started with this PouTA environment. So if you would go into that one, then you would find how to set up a virtual machine in CPouta, and then a few more extra instructions. So depending on what you are interested in, you might want to look into one or another. And if we go back to the main PouTA page, then you can see that there is also instructions on how to set up Docker applications. You can be interested in looking into that one. And GeoServer and PostGIS and these RPy instructions. So it would look something like that. We will get back to this GeoServer in a minute, but just to show you again what the Rahti part looks like. This Rahti part actually has so far quite little of GIS element, but it's mandatory know-how before you can get anything ready. So for that purpose, we actually created these instructions so that you can, in a structured way, get little by little forward until you can actually deploy or publish or run your applications in Rahti. So, and I'll go back quickly just at the end because there's not so much time for today. But I'll go back to those instructions so that we can quickly have a glance of what this Rahti platform looks like. But if we now kind of try to imagine that we would like to set up a PouTA application or PouTA virtual machine running GeoServer or PostGIS, but in this case we would go for GeoServer, then you could just come to these instructions, and what you would do, of course, is look what we have been preparing, and inside this topic, you can find that there is a how to install GeoServer and even how to upgrade it. And we have also a use case description in here. So hopefully this is useful for you. And if you have any questions and comments and things, you can actually always send us an email, CSC, to service desk at CSC. So maybe Mikael can actually write also this service desk at csc.fi in the chat. So this is always the entry point for any questions that you might have, because those questions will be directed to the best expert on the topic, and we can actually share quickly and easily any question within our colleagues. But so any kind of questions you can direct in there. Also regarding any comments that you might have to this repository that we have. But the most important part, I would think, in this GeoServer installation instructions or GeoServer documentation is these instructions, and how we have been trying to write these ones is that there is some, of course, these instructions are based very much on what is publicly available, so it's nothing that we have made up. But anyways, they have been tested within PouTA environment, and they should relatively easily work for you too. But if you have any problems with running them, you can always contact us. And actually, it's very common because these are software installations that you might need to update some parts of the script. So it's not only just copy paste and running whatever it is in these instructions, but unfortunately, this software development goes so fast that there's always something new. Like, for example, Java is always giving problems because it's somehow developed in strange ways, I would say. But anyway, you can see here some prerequisites that you would have to need to run these GeoServer installations. And you can see that there is a description of what type of machine you would need, for example. And you always need to define these security recommendations because you are using cloud virtual servers. So there's always a risk that somebody could break into your computer. To be aware of how to define this have some instructions in that basic PouTA instructions that we have in our repository, plus the PouTA instructions. But in the end, what you would end up doing is read little by little, because there is important bits of information in the text, and then you would run this kind of commands that are very typical for Linux environments. In this case, it is an Ubuntu machine that we are using in this example. So this would be the best starting point. If you start with a different operating system, then you would need to adapt much more the instructions below. But if you start with those ones, then you can actually probably be able to just run anything that it's in here. And what you would do is kind of connect to your virtual machine, and it would look something like this. And then what you would do is little by little copy one instruction at a time, thinking if it is necessary that you modify it somehow. And then you would be running them in your virtual machine, and so on for all the rest of its instructions. And I just did this before the webinar, and I ended up with this. So in the end, you get this kind of machine by simply following up these instructions and running these commands. And even there is some instructions on how to manage this environment later on for different purposes. So hopefully these instructions are very useful for you. Unfortunately, we probably don't have instructions for every possible application that you might be interested in, but at least we have these ones, and we are open to suggestions. And if not, by looking at these examples, you can hopefully be able to implement your own applications in a similar way. But here, what we ended up having is a basic GeoServer installation, as you might have noticed or have seen before. Right, so please ask any questions already, because we are getting to the end, so I have time to answer. So if you have some questions about this GeoServer, now this would be an interesting point, but you can come back later after you have some time to actually test these machines or these instructions yourself. But I wanted to quickly also show Rahti. And as I was saying, this is the main page for our Rahti. So far, GIS instructions, actually quite general. So if we would go back to the main entry point, this geocomputing repository, then you could actually go to this Rahti containers platform. And in the instructions, you have a first disclosure of what you would need to know before you can actually follow up these instructions. It's always, of course, you have to have an active account in Rahti, which at the moment is not is on request. So you could actually send an email to service desk at csc.fi, and you could ask for a Rahti account in there and mention what are your needs and see if you could actually get access to it. It's actually possible. And you would actually then need to learn how to use this Rahti platform and OpenShift commands. There is some instructions, and of course, here below. And of course, you have to know basic management of Docker and Docker files. So that's something you need to know to learn by yourself. And when you know all those things, you realize that, of course, you have to have an environment where all these tools are actually working. So, but for this, we have already some instructions. So you would have this Docker environment where you would be able to set up your own Docker enabled environment. So you would end up having for example, a CPouta machine, or you could actually install it in your local computer. I would recommend to use a server machine. It's always nicer when you don't need to have your computer stuck to doing some computations. Actually, building Docker containers, it might become quite heavy at some times and take 1 or 2 hours. So it's always better when you have a separate environment where you can do those kind of installation stuff. And then there's some other instructions. We don't have time to go through all of them. No questions so far in the chat, but this creating a custom container. So in the end, our goal is to have some application that runs some specific tool. So, and how you do this, and we have written these instructions with the goal in mind that you would get these applications running from Rahti and or from notebooks. So this step, the angle that these instructions have been written, or the idea that these instructions have been written for. And as you can notice, immediately you quite quickly get to this kind of computer commands that you need to run, and this is just necessary that you are able to do these things. But if you have already done the first step, which is getting your Rahti enabled environment, Docker and Rahti enable environment, then you can actually run these commands from these instructions. And in a way, you are setting up your Rahti project with these commands. Then you are logging into this Rahti platform. And then in the end, you are registering yourself or logging into Rahti registry, which means that you are able to upload images to this Rahti's platform, where you will be able to run these applications. If in the end, what you would like to do when you look through this instruction a bit farther, you would kind of end up writing yourself this kind of Dockerfile script, which is actually based pretty much on one of the templates that are mentioned in the instructions before. Now, when you, for example, would install your own, so to say, software, in this case, it will be GIS Python tools that you would be installing. So in the end, you will have a JupyterLab environment, which is very common in this Notebooks platform, but it will have this kind of geocomputing related Python tools installed. And we'll see in a moment what it looks like, the end result. So you end up with this kind of a script, and then by running this kind of building a Docker image command, and then uploading this image to Rahti platform, you get to a point where you can go to your Rahti platform, which looks something like this. Maybe for you it's a bit different. You can see I'm logged in here on the upper right. And then you can go to your project. In this case, we have these GeoPebbles images. And let me click on the project itself. Nope. I wanted to see, this is the registry where I have these images. So I would have ended up having this, not that one, but some kind of GIS, actually it's GIS image. And from an image, you can always deploy one application, as in here from this menu. You could always deploy an image, and there you would set up what script did you use to create this image. For example, this data science geo. And once you have done this and name it somehow, geo2, you would deploy an image. And that means that it creates a new application in the Rahti platform. To be able to do this in Pouta, you would need to install a Docker software and set up different ports and things like that. So once you have started your application, you actually have to create this kind of link from the platform. And by clicking on, or by going to this address, you actually end up having your application running, and it looks like this. And this is a simple JupyterLab container that is running in Rahti platform in the backend, and which actually has all these Python tools installed that we actually added to the template. So you can see we have GeoPandas here in the list of installed libraries. And when I go to this JupyterLab, I can write Python code and use GeoPandas and any other GIS tool that I might have installed in there. And if we want to go I didn't prepare this one, but if you go to Notebooks, actually it's a not so long step anymore that you would not need to start your application in Rahti, as we did manually in here, but you could actually set it up to start from Notebooks. And what the same application would look like in Notebooks would be something like that. You would just click in Launch Application, and depending on how fresh your application is, it might start in a few seconds. But the end result would be the exact same one, and every student would be able to log in and start same application. But hopefully you can actually repeat the steps from the instructions of our GitHub, geocomputing GitHub, for PouTA or Rahti. And definitely if you have any questions or suggestions, or you find some problem with the instructions, you can always let us know. And the best way is always to address your questions to this service desk. You can actually also use this GitHub platform to send issues or things similar to that, but perhaps this service desk email is the most efficient way. It will reach us quite fast. And so far, that's all. If there's no any questions, you can send them later on. But I'm happy to still have a few minutes to answer or show you something if you think that it's that you would like to see. If you have any suggestions to run a basic command in this using GeoPandas, you can also send it in the comments, and we can try if it works. I just don't have any snippet code now here, nor I have any data in this container. Okay, we had our notebooks image also running already. So basically that would be the same. The same environment that we run directly from Rahti, but this has been started from Notebooks. Yep. And actually, since this is this kind of course environment, I think I might be able to run some examples. This is actually a repository from Henrik Stenkanen course. You can see from internet yourself. So this is what Jupyter notebooks look like. And the nice thing is that you can embed text descriptions and code snippets that you could run, or the students could run and test that things are actually working or not. Probably some data is missing in this example, or I didn't run some previous command. Yeah, data is missing. Yeah, but please try to make as much use as possible of this GitHub repository. And if you have any questions or suggestions, please get back to us. See you next time. No questions so far.